Why is the attosecond laser worth a Nobel Prize? The 2023 Nobel Prize in Physics was awarded to 3 scientists who have studied attosecond lasers, but most people around them who see the word attosecond laser are like reading Martian script and don't know what it is. If we go back to before 1960 and describe lasers to anyone in the world, it's almost like describing colors to a blind person. It's difficult for them to understand what lasers are. But today, you can buy a laser pen for 5 yuan, and kindergarten children know what a laser is. However, most ordinary people can only think of one word when describing lasers, which is color. In our impression, lasers are colorful. The essence of laser color is the frequency, or wavelength, of the laser. The relationship between wavelength and frequency is a simple conversion, and their product is equal to the speed of light. Can you think of more adjectives to describe lasers? Yes, you may have thought of brightness. That's right, the higher the emission power of a laser pen, the brighter and hotter it becomes. Some laser pens available on the market can even light matches. Is there anything else? I guess I can't figure it out, can I? In fact, for professionals, there is another very important parameter to describe laser, which is called pulse width, abbreviated as pulse width. To understand what attosecond laser is, the key is to understand what pulse width is. Some lasers can divide the laser into small strands and shoot out at extremely short intervals, which is called a pulse laser. However, our human eyes have visual remnants. When the frequency of emission reaches a certain level, the naked eye cannot see individual laser bullets, and what we see is still a continuous beam of laser. The advantage of pulsed laser compared to continuous laser is that it can obtain higher power. The smaller the laser pulse is divided, the faster the frequency of emission, and the greater the energy of each laser bullet. Scientists refer to the interval time of each laser pulse as pulse width, abbreviated as pulse width, so the unit of pulse width is the time unit. A laser that emits a laser bullet every 1 second, with a pulse width of 1 second, can be called second light. However, for pulsed lasers, 1 second is too long and we need shorter time units to describe it. Then, there is nanosecond light, which means that the laser pulse width is equal to 1 nanosecond, that is, 1 billionth of a second, and 10 to 9 seconds with scientific notation. A further decrease in pulse width is called picosecond light, where 1 picosecond is equivalent to 1 trillion millionth of a second, ranging from 10 to 12 seconds. Another smaller level is called femtosecond light, which is 1,000 trillionths of a second, 10 seconds. The next level is the attosecond light, in this Nobel Prize in Physics, where 1 attosecond is equivalent to 10 billionths of a second, 10 seconds. This number is too small for ordinary people to have a concept. Let's put it this way, if we imagine 1 second to be as long as 1 second, then 1 second is equivalent to 31.7 billion years, which is more than twice the age of the universe. So, the attosecond laser is the shortest time interval that humans can produce so far, and the method of producing attosecond laser was invented by several Nobel laureates this time. Simply put, using a femtosecond laser to bombard an inert gas can excite a smaller pulse width attosecond laser. Bombardment of different inert gases can produce different types of attosecond light. The asecond laser has opened the door to the extremely fast motion process of electronic research, creating a powerful tool for humans to further study the micro world. It is almost impossible to directly explain this knowledge related to the field of quantum physics. As a science popularization expert, I can only use analogies to enable ordinary people to roughly understand it. But I want to emphasize again and again that analogy is never true physics. You can only treat this way of understanding as a social currency, and it's okay to boast at the dinner table. Don't daydream and invent your own theory on this basis. Anyone who has played photography should be able to understand what shutter speed is, right? The faster the object we want to shoot moves, the higher the shutter speed is required. If the shutter speed is not enough, the resulting photos or videos will have dragging shadows. In video shooting, there is a parameter called frame rate, FPS, which means how many photos are taken in 1 second. The video we shoot with our mobile phone usually takes 30 photos per second at 30 frames per second, which is basically enough to record the images in daily life. However, if you use your phone to capture a picture of water dripping into the water, you can hardly capture anything because the speed of water dripping into the water is too fast. However, if we use a high-speed camera to capture water droplets entering the water, we can clearly see the entire process of water droplets entering the water. The higher the frame rate of the camera, the more details of high-speed moving objects can be recorded. Early high-speed cameras, in order to achieve higher frame rates, were really desperately increasing the opening and closing speed of the shutter. There was really a high-speed opening and closing gate in the camera. But when we think about it, we also know that by using this mechanical method to increase the speed of the shutter, it will quickly hit the ceiling and cannot be too high. So what should we do? Engineers came up with pulsed lasers. Think about it, the essence of pulsed laser is actually similar to that of a shutter, which is to complete an action within a certain interval of time. If an object is moving at high speed, we irradiate it with a pulse laser. In theory, it is one bright and one dark, just like the photosensitive device of a camera being exposed time and time again. Then, we collect the laser reflected by the object to form a data stream, and use algorithms in the computer to restore the appearance of the captured object. You can imagine a continuous firing machine gun in your mind, with a rapidly passing car in front of the muzzle. If the frequency of bullets fired is not fast enough, it is likely that you will not be able to hit the car, or you will only be able to hit it a few times. The fewer bullets bounced off, the less information we receive about the car. So, a laser with a smaller pulse width is equivalent to a laser gun with a faster emission frequency, which can capture objects with faster motion speeds. Various chemical reactions, such as crystallization, can be captured using nanosecond light. Molecular scale motion can be captured using picosecond light. Atomic scale motion can be captured using femtosecond light. And using attosecond light can capture the internal motion of atoms, which is at the electronic scale. For example, attosecond light is like humans finally creating a probe that can penetrate the interior of atoms and directly touch electrons. This is the limit of the micro world that humans can directly detect at present. This is the Nobel Prize in Physics this year. Do you understand attosecond?